Welcome to homework.
So in this problem, we have a beam that is inclined, and it is, let's see here, it is supported at the lower end down here by a pin joint, and at upper here by essentially a roller. So we only have a horizontal force up here, and we have both horizontal and vertical forces down here. Let's see, there are basically the external load is essentially its own weight. So this is a problem where we have to be a little bit careful about things. Again, this makes a 3, 4, 5 triangle here, so we can get the angle from that. But we have to be a little careful about this distributed load here. Obviously, we can lump it at the center when we look at the entire structure, but when we just look at a piece of it, then we have to be careful and move it. Just consider the distributed load over that piece. So for the entire structure, we have P2 plus P4 is 0, and P1 minus P3 is 0. And then this distance here is 3 feet. So we have minus 3 times P3 minus 8, because this distance is 8 times P4, and that has to be 0. So that would give us, that gives us 3 equations, and we could find P1, P2, and P4 from those. I just solved everything all together. So then I took a cut here, which is at point C in the figure. And so we take a look at this little chunk. And so now we have V, our shear force, and our normal force are inclined with respect to the x and the y axes. So we need to take their components. So the component of V in the x direction is 4/5 V, and it's negative. Then we have plus P2. And then the component of N in the x direction is 3/5 N. So again, the magnitude is N and V. And then in the y direction, we have 3/5 V plus P1 plus 4/5 N minus P3. And now P3, you have to remember, is just the weight of this piece here. And so the beam, we were told the beam weighed 280 pounds per foot. And this is now a 3 feet section of it instead of 10 feet. And then we can look at the moments on this little chunk, and we have this distance here is the moment arm from V is 3 meters or 3 feet. Then we have our point load M acting, and then we have the external load, and so that acts at the center of this section, which is well, it's up 3 feet, but then we need to take the component of that vector in this direction, so that's 3/5. So the moment arm is 1.5 or 3/2 times 3/5 and times P3, and that's a negative moment. So in the end, we wind up with actually 6 equations and 6 unknowns. Obviously, we could divide them up into these 3 and then these 3. But if we solve them, what we find is that P1, so P3 and P3A, I've called it here. These are the weights. Okay, so this was 10 times 280 pounds per foot, and then 3 times 280 pounds per foot. So in the end, we get P1 is 2,800 pounds, P2 is 1,050 pounds, and P4 is minus 1,050 pounds. And that all makes sense. You can basically see that 2 and 4 have to sum to 0, and this needs to offset the weight. Now when we take the cut and we can look at these equations, we can use these results here, in here, and now we can solve for N, and it is minus 2,198 pounds, V is minus 336 pounds, and M is 1,764 foot-pounds. So that makes sense. So basically this says that N is compressive, and which we'd expect because this is basically the weight is acting to compress the beam. And again, the shear is in the opposite direction as illustrated here, and that seems like that would be reasonable.